Hello there, folks. Kind of an interesting video today. We're going to show you how to configure an AutomationDirect Productivity PT-550 PLC to act as a Modbus TCP slave so that your redline HMI can pull it as a Modbus TCP master. So this is just a picture of the PLC that we're going to be using, and I'm going to show you in the AutomationDirect software how to configure this thing to act as a Modbus TCP slave. So I'm going to go over to their software called the Productivity Suite, and I've already got chosen this PLC. So I'm going to double click up here on the hardware config, brings up this picture here, and here's the PLC module here. So I'm going to go ahead and double click on this PLC module to bring up its settings. And in this case, I'm going to go to the Ethernet ports tab right here. And notice here, it's got the port name here. Important thing is I'm going to have access as read and write. And in this case, I'm going to set the IP address of the unit. So in this case, I'll set it to be 192.168.1.123, for instance. Whoops, I hit enter. So let me go back to there. So right here, I hit enter by accident. And I want you to notice that on this screen, with the read write here and down here, Modbus TCP port's already declared as 502, which is the standard. So that's correct. So that's already turned on. You want to make sure that you've got the access here set to read and write. Okay, so I got that done there. Nothing I need to do here, nothing over here. Everything else is fine. So I'm going to click the OK button. And none of these other tabs, you have to do anything else in these other tabs. We're going to be using Modbus TCP. As long as we have that set up over here on the port, we're good. So we'll go ahead and close that down. And I'm going to go over here to the left and go to Tag Database. Over here in Tag Database, so I'll double click on this. It might come up where it's got all the checkbox, whatever here. I'm going to go ahead and turn all that off. So we turn that off. And I'm going to go ahead and add some new tags here. So I'm going to click Add Tags. And let's say that I create this one as Wazoo's, we'll call it Wazoo's underscore ints, like this. And I'm picking this name because I'm going to declare these as some 16-bit integers for this example. And if you notice right here, it's got this Modbus addressing here. So there's that 40,000. If you're familiar with holding registers, Modbus, that's what it's doing. And I'm going to say this is going to start at 1 here. And let's pretend that I'm going to create 10 consecutive tags here with this. So I'm going to click the Add button. And you can see in the background that it added 10 tags here of this setting. Now let's say that I want to add some floating point numbers here, for instance, some reals. So I'm going to call this floats. And I'll go down here and I'm going to pick the float 32-bit here, this guy right here. Now, if you recall, we had previously set this to 40,001 here. So if I hit add this time, the software is going to kind of bark at me. Let's see. It's going to set one or more addresses are not available. That's because I'm already starting here. So what I've got to do is I'm going to change this to address 11 because I'm pretty sure that my first 10, which is in the background right here, let me move this out of the way. The first 10 are in this column right here. So if I make this show up here, start at address 11 and hit add, now it's going to add these floats. So I'm going to hit the close button, and there's a bunch of columns across here that you can make wider and so forth, but the ones that are important here are the Modbus end and starting addressing here. So if you look here, my first 10 integers are 40,001 to 40,010. Those are ints. This should be 0. Well, anyway, it's 0 through 9 is 10. And then my floats start at address 11. Because they're floats, they're taking two 16-bit integers and making it into a 32-bit floating point. You see that each one takes up 2 consecutive registers. So I know, based on what I see here, that my first 10 are integers, 40,001, and the next 10 or 20 registers really are my floating point numbers. So that takes care of setting up those. Now, if I wanted to, let's look here real quick here. If I go here to System Data, there's these other registers that are in here as well. There's a bunch of registers in the AutomationDirect thing that you can look at. And I'm just going to look and see if I can find something here that might be of importance. I have no idea what this, let's see what this Ethernet speed here is. So if I double click on this, let's see if I get anything. No, nothing. Okay, let me see here, team. I'm going to be last. I wonder if I can change. Nope, I can't. I was going to see if you could modify them, but I don't see where you could map that to something. So I guess you'd have to use a function in their code to map that to one of your other registers. However, let me turn that off. All of these are going to be available in Modbus over these registers. So I'm going to go ahead and close this down. That takes care of setting up the registers in the AutomationDirect PLC. So what two things do I need to know? Well, I need to know the IP address that I set up with this guy, which was 192.168.1.123. And let me close that again. And I needed to know, of course, the tags I set up. This column here, you might have to make these smaller, but you can see they give you a Modbus end and starting for those. So that's where it's declared in the AutomationDirect software. So I'm going to go back to Crimson now. And in Crimson, I'll go over here to Communications. And on Protocol 1, I'll hit Protocol 1, hit the pick button. I'm going to set this guy up as a Modbus master, TCP IP master. I'm going to click on that one because the AutomationDirect PLC is going to act as a slave. So I'll click OK. And then over here, where it says PLC1, I might change this name to AD for AutomationDirect underscore. I'm using a P2-550 model. So I got to make sure that, of course, the IP address here matches. So this is going to be 123. And because I have a default device starting at 40,001, I can leave that at a 1. If I didn't have my first register mapped to 40,001, I'd want to make sure this number here matches, go back to here, matches whatever one of these numbers in here. It has to match here. Now I happen to have started at 40,001, but you want to make sure it matches. So back here at Redline software, that takes care of setting up the driver. Now if I go over here to data tags, I'm going to go ahead and create a new integer tag right here. And I'm going to follow the same suit I did before. I'm going to call this one Wazoo's underscore ints. And then I'm going to do underscore 0 right there, just to follow the same as the other guy. And then I'll hit the source here, pull down, go down to the AutomationDirect right here. There's that PLC we just declared. Click on that. Everything is mapped into the holding registers. So in the AutomationDirect, you saw 4. Here's that 4 here, and there's the starting. I'm going to leave it as word. That's our way in Redline of indicating that's an integer. And I'll click the OK button here. And now that first one is mapped right there. Default integer, I've got it declared as unsigned in the AutomationDirect, so I'll just call this an unsigned. And now if I want to do a mass populator of these, the beauty here, team, is you can use the smart duplicate button right here to do that. So if I click on this guy here and click this, boom, 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 and I'm going to go all the way down to where I get number 9. I stopped at number 9 because that's the last one here. If I go back to the AutomationDirect, you can see right here, that's this guy right here. It ends at number 10 here. Yep, that's correct. Let me go over here. Yep, that's correct. It matches right there. Now I want to do the floating point numbers. So I'm going to do the same thing. I'm going to click a new button here. Get a new tag. I'm going to go ahead and immediately change this to Wazoo's floats. And I'll do underscore 0 again. And then these, if I go back to AutomationDirect, my first float starts at address 11 here, and it's a 32-bit number here. So that means in Redline software, I'm going to go down here, choose this guy, do holding registers, change this here to number 11. However, I'm going to do the type down here as a word as real. That will make Redline software grab 2 consecutive 16-bit integers and put it together as a floating point. So I'll choose word as real. You can kind of see it puts a dot real here. And I'll click the OK button. And now, if you notice something interesting, our software automatically converted that to a floating point. And if you've ever attended one of my classes, the pi symbol here indicates that's a floating point number, whereas the x is an integer, the pi is a floating point number. So now if I wanted to do my mass update here of these guys, What I mean by mass update is we've got 10 of these over here, team. So that means in Crimson, I'm going to use the smart duplicate, boom, 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 till I get down to number 9. Can't see it right there, so I'll go down a little further. One more. Notice that one, number 9, ends or starts at number 29 here. Let's check our math over here and look right here. This guy is stopping right there, and that is absolutely correct. So that would take care of matching all of those up into AutomationDirect. So that covers that part. Let me go a little further here. What if I said to you that first integer, I wanted to look at bits within this first guy right here. I wanted to look at individual bits. Now I did not declare over here in AutomationDirect, I didn't declare these as booleans. I declared them outright as 16-bit integers. But if I wanted to focus on specific bits within this word in the red line software, what I'll do is I'll go over here, make this a little smaller here, and I'll go ahead and I'm going to click down here, and I'll do a new tag. I'll just do a new flag tag. A flag tag in the red line software is a boolean tag. So I'm going to click here, and I'm going to call this one Wazoo's. We called them ints earlier, which is right, but then I'm going to call this a bool underscore 0. Okay, let me click away. And the reason I chose the word bool and underscore 0 is because I want to map this guy to the very first bit of this one. So watch what I do here. I'm going to click here, hit the pull down, go down to the same PLC, click here. I'm going to leave it default 40,001. Word is word. That's okay there. Click OK. However, now if you notice in the red line software right here where it says treat as unsigned integer, well, if I hit the pull down here, I can break that word up into an array of 16 bits integers. I'm not for sure if the AutomationDirect follows a bit array little endian, which means bit 0 comes first, or big endian, where bit 15 comes first. So I'm going to go with the little endian because that's what I got more experience with other companies' products. So I'll choose bit array little endian. And now look, team, now the bit number is selectable. So if I was to hit the pull down here, you can see that I can explicitly choose different bits. Well, I'm going to leave it at bit 0 because I want to show you something here. I'm going to take advantage once again of the smart duplicate button and see if I can map this to all 16 bits within that word. So if I click here, highlight that guy, and use the smart duplicate, let's try it. 1, 2, 3, 4. I just did a few, and I want you to notice as I do that, the bit number automatically increments and the label for the tag automatically increments. So if I wanted to look at all 16, I'll just keep going down until I get to bit number 15, which is going to be all 16. So here I am at bit 15. Now the question would be, that's the last guy here, if I hit this button one more time, what's going to happen is this is going to roll over to the next word, and this is going to go to bit 0. Watch, I'll hit it, boom. So now, effectively, this guy is looking at the first bit of the second, not floats, way up here. It's now looking at that, but that's not what I want. So I'm gonna delete that. I want to confuse you. So that means all of these are effectively individual bits of this word. And so that's a quick example of how you can set up your AutomationDirect PLC to be a Modbus slave. The key thing to it is you got to make sure, let me just reiterate, on the hardware config, when you configure this thing, on the Ethernet tab, Ethernet ports here, you got to make sure your security is set up for read and write. And of course, you got an IP address. The port number is 502. That's the standard. That's the first thing. And then when you go configure your tags in your AutomationDirect, you've got to map them to your Modbus register. So as you add, let's just recap one more time. If I add a tag here, you put a name up here and you pick what kind you want here. Something interesting here. I'll point out, I always like dealing with the holding registers because they're bidirectional. But as you go to booleans, here you can see, look, that's the 0 register, which is known as typically the coil registers in this case. I don't know if they give you access to the 1000 registers. No, they don't. I don't think they do. No, nope, they stick pretty much with the either the 0 registers or the holding registers. And I typically work with the holding registers. So anyway, that's just a quick example, team, of how you can set up your AutomationDirect PLC to talk to the Red Lion HMI as a Modbus TCP slave. That is the preferred route to go. If you make your AutomationDirect slave be the master, then you've got to use function blocks in your ladder logic, and that requires a lot more work. So I recommend that you set up your Modbus, your AutomationDirect PLC as a Modbus TCP slave, and just map your data tags over to the appropriate registers. Thanks a lot. Have a great day, folks.